In this lesson, I'm going to talk about arcs and angles that are in and on circles. So if you open up your circle book, my recommendation would be to make those two, or actually the one diameter, segment AE, and then the two radii, segment CD and segment CB. Put them in there similar to what I've done, and then name these four angles: angle 1, angle 2, angle 3, and angle 4. Because we're going to use this as I go through making your notes for today. So the first thing we're going to talk about is a central angle. So any one of these angles that I have marked is a central angle because the vertex of that angle is at the center, and then each side of the angle is a radius of the circle. So it has two radii as sides. And then I have a little formula here that says if we take all these angles, add them up, it's going to equal 360 degrees. Now the next thing we're going to talk about is what's referred to as a minor arc. It's part of a circle. As you can see here, what I have highlighted in green, and it has two endpoints, kind of like a segment, but obviously it's not a segment because it's not straight, and the measure of it's always going to be less than 180 degrees. Now the way you're going to actually calculate the measure of that arc is to measure the angle that I look at as creates the arc, or we'll say that the arc is intercepted by an angle. So in this case, if I want to find the measure of arc BD, I need to measure the angle that creates it. So I go to the center, which is right here, and I'm going to measure this angle. Get my protractor lined up, just like so. So now I can see that one side of my angle is here, it's at 0, and then follow the numbers around on the outside until I get to the other side. And I find that the measure of my angle is approximately 139 degrees. Now that tells me that the measure of the angle, that central angle, is 139 degrees, but that also means the measure of the arc is also 139 degrees. So now when I look at this, the measure of my arc BD, and the measure of angle BCD are both 139 degrees, and that will always happen. The measure of the central angle is always going to be equal to the measure of its intercepted arc. Now my next one is going to be the major arc. Well, if the minor arc is the one that's less than 180 degrees, the major arc is going to be the one that's more than 180 degrees or greater than 180 degrees. Now it's kind of hard to calculate or to use the protractor to find the measure of the major arc directly because we can't measure the central arc, which would be right here, angle 2 and angle 3 put together. We can't measure that with a regular protractor. So what we can do is we can measure the angle on the other side, call it, and then subtract it from 360 degrees. So that's what I'm going to do to find the measure of arc BED. I'm going to measure this angle, which I already have, it's 139 degrees, and then I'm going to take 360 minus the 139 degrees. When I do that, I find that the measure of this major arc is 221 degrees. And now we know the measure of the major arc, arc BED, and the measure of the central angle are both 221 degrees. Now what I want you to notice, something that I pointed out here, is when I was talking about the blue arc, the major one, I used 3 points to name it. I'm always going to use the end points, and if it's a major arc, I have to use one more point that's on the arc. When you talk about a minor arc, like I did with the green arc, I can get away with just using 2 points, the 2 end points, to name it. So you got to be aware of that. Anytime you hear 2 points to name an arc, it's always going to be a minor arc. If you hear 3 points, now that could be any kind of arc, but at least you'll be able to follow it around. So arc B, E, D, follow it around. The green arc could also be referred to as arc B, A, D, but you can get away with kind of that shortcut of just using 2 points when naming a minor arc. So that's the difference between the major and the minor arc. Now, the last arc that I'm going to look at is half the circle, referred to as a semicircle. And you always have to use 3 points to name that one as well. It's just like the other arcs. You have to use the 2 end points. So in this case, it'd be point A and point E, and then one more point that's on the arc. So in this case, I used B. Because you can't just say arc AE, because we wouldn't know if that's the arc on the other side of the circle or not. So the arc that the semicircle over here would have to be referred to as arc ADE. But the one that I have highlighted is arc ABE. And the measure of that's always going to be 180 degrees. You don't have to measure it because it's half the circle. And the last thing that I have here is just a little formula. It's going to help us find the arc length. Now, arc length is just what it says. It's the length of the arc. So if I wanted to figure out how long this green arc was, I could use this formula. And basically what I think of as arc length is I like to think of it, if I took a scissors and snipped here, and then stretched this out, the green arc, so that it was straight, how long would it be? Would it be 2 inches? Would it be 3 feet? What is it? And we can use this formula to do that. Now this degree measure, that would be the measure of the arc. So you may want to put that next to this where I put degree measure, put the measure of the arc, and then divide it by 360, and then it's the arc length, or the length of the arc, divided by the circumference. Now what you notice here is this is nothing more than a proportion. So on this side, this is all dealing with measure, or in other words, degrees of the arc, and then the whole thing. And then this is length, whether that's inches, centimeters, feet, etc., some sort of linear unit of measurement, and then over circumference. So I like to think of it, it's the part of the circle over the whole circle in terms of degrees, and then it's part of the circle over the whole circle in terms of some sort of linear measure. And that's going to help you really, I said calculate arc length, but it could help you find the circumference. It could help you find the measure of the arc as well. As long as you know 3 of these things, you'll be able to solve for the other one. And that's going to conclude the lesson portion on arcs and angles inside of circles.